Okay, today we'll discuss the what is integral equation, what are the types of integral equations, how to classify integral equation, how to find a solution of integral equation. Okay, today we will discuss the general methods. Okay, the later we will discuss the shortcut tips to solve the integral equations to find the resultant kernel. Okay, there are some shortcuts. Tricks are there. First, we can start from the beginning. First, to see the definition of integral equation. Okay, so an integral equation, an integral equation is an equation. First of all, it is an equation. Okay, integral equation is an equation in which an unknown function and unknown function, very important this concept, unknown function appears under integral sign, integral sign means integral equation is an equation first of all. Okay, unknown function, that means y of t or y of x, whatever the function which appears under the integral sign. Such type of equation is called the integral equation. For example, you can see the equation y of x is equal to, for example, first I am taking a simple example, y of x is equal to some integral a to b. Okay, these may be constants, they may be variables. K of x comma t, y of t dt. Here, y of k of x comma t is the known function, y of t is unknown function. This unknown function appears under the integral sign. So that this is an example of integral equation. Similarly, if we take another equation, y of x is equal to sin x, you may take any function. Okay, we are taking sin x. Integral particular limits 0 to 1, sum k of x comma t into y of t dt. Here also k of x comma t is known function. Sin x is also known function. Y of t is unknown function that appears under the integral sign, so that it is an example of integral equation. And I am taking another example, e to the power of x plus integral 0 to x k of x comma t into y of t into dt is equal to 0. Here y of t is unknown function which appears under integral sign, so that it is an example of integral equation. Similarly, we can take another equation, y of x whole square is equal to integral 0 to x sum k of x comma t into y of t into dt. Okay, these are the examples of integral equation. Simply, we can remember an unknown function which appears under the integral sign. Then that integral equation is called integral equation. Okay, and the most general form of an integral equation, you can remember this as a basic form of the general form of the integral equation. It is of the form g of x into y of x, that is equal to f of x plus lambda into integral a to b k of x comma t into y of t into dt. Okay. G of x, y of x. F of x is equal to f of x plus lambda integral a to b k of x comma t y of t dt, where you should remember this is the general form of the integral equation, where f of x and k of x comma t, f of x and k of x comma t are known functions, known functions, known functions, and y of t is unknown function, is unknown function, unknown function. Then this function, this equation is called general form of integral equation. Okay. So we are given for the values of f of x and k of x comma t, we need to calculate y of t, that is unknown function. This is the general form of integral equation. Okay. So we can classify integral equations into several types depending on situations. Okay. First, classification of integral equations. Integral equations. Actually, the main classification is only two. That is Volterra integral equation. Volterra integral equation. And the second one is Fredholm integral equation. Fredholm integral equation. This is the main classification. Okay. But we can classify integral equations into by depending on y of t, g of x, f of x, and limits of integration. We can classify into several types. First, depends on y of t. First case 1, depends on y of t. We can classify integral equations into three types. First one is a linear integral equation, linear. Second one is non-linear. Second one is non-linear. And third one is singular integral equations. Singular integral equation. Depends on y of t. Okay. According to y of t, we can classify integral equations into three types: linear integral equations, non-linear integral equations, and singular integral equations. And case 2. In case 2, depends on g of x. Depends on g of x. We can classify integral equations into again three types. First one is first kind integral equation. First kind integral equation. Second one is second kind integral equation. Second kind integral equation. And third one is third kind integral equation. Third kind. Okay, we can see the definitions later. First, depends on y of t. Integral equations classified into three types: linear, non-linear, and singular. Similarly, depends on g of x. The integral equations are classified into three types: first kind integral equations, second kind integral equations, and third kind integral equations. And case 3. Case 3. depends on f of x. Depends on f of x. We can classify integral equations into two types. Okay, two types. First one is homogeneous integral equations. Homogeneous integral equations. And second one is non-homogeneous integral equations. Non-homogeneous integral equations. Okay, according to f of x, we can classify integral equations into two types. One is homogeneous, another one is non-homogeneous. And fourth case, very important case, fourth one. Depends on integral limits. Depends on integral limits. That means lower limit and upper limits of the integration. We can classify integral equations into two types. First one is Volterra integral equation. Volterra integral equation. Very important. And second one is Fredholm integral equation. Fredholm integral equation. Okay. We can classify integral equations by depending on integration sign. Depends on integral limits. We can classify integral equations into two types: Volterra integral equations and Fredholm integral equations. Okay, this is the main classification of integral equations. Okay, depending on y of t, depending on g of x, depending on f of x, depending on integral limits, we can classify into several types. Depending on y of t, we can classify into three types: linear, non-linear, and singular. Depending on g of x, we can classify integral equations into first kind, second kind, and third kind. Similarly, we can we can classify integral equations into homogeneous and non-homogeneous by depending on f of x. And a very important case is the Volterra integral equation and Fredholm integral equation. That can be defined, that can be depends on integral limits. Okay, you can see the one by one definition. First, see the linear integral equation. Okay, linear integral equation. Simply, already we know that uh, linear integral equation can be depends on y of t. Okay, that means the function, the integral in integral equation, the unknown function is in linear form. That means y of t is in linear form. Then that integral equation is called a linear integral equation. That means an integral equation, an integral equation is called linear, if and only if unknown function y of t, unknown function y of t is linear form, is in linear form. Okay, when y of t is in linear form, then that integral equation is called a linear integral equation. If it is not linear, y of t is not linear, that is called a non-linear integral equation. For example, okay, you can see the otherwise it is called non-linear. Means an integral equation, an integral equation is called non-linear. Non-linear. If and only if it is not linear. It is not a linear integral equation. Okay. You can see some examples here. Okay. So if we consider an equation, y of x is equal to, g of x into y of x is equal to some f of x plus integral 0 to 1 k of x comma t into y of t. Okay. Here the power of y of t is 1, so that it is a linear integral equation. This is linear integral equation. Okay. Similarly, if we consider another equation like f of x is equal, y of x is equal to f of x plus integral 0 to 1 k of x comma t into e to the power of y of t into dt. Okay, you can see here e power y of t means we can expand by using e power x expansion. So y of t is more than 1. Okay, it may be 2, it may be 3, it is and so on. Okay, so it is not a linear integral equation. So it is non-linear integral equation. Okay, this is best example for non-linear integral equation. E power y of t or sin y of t or cos y of t. Okay, such type of integral equations are called non-linear. We can remember when y of t is in linear, that is called linear integral equation. Otherwise, non-linear integral equations. These are the two examples of integral and linear and non-linear integral equation. And one more classification depends on y of t, that is singular integral equation. Singular integral equation. Okay. This is also depends on y of t. Okay. An integral equation is called singular integral equation, or simply singular if at least one limit of integration is infinite. At least one limit of integration is infinite, or another word is kernel becomes infinite under the integral sign. Okay, that means the function, if we take a equation, if y of x is equal to f of x plus integral, sum I am taking minus infinity to plus, at least one limit is infinite. Of integration is infinite, that is called singular. Otherwise, kernel becomes infinite under the integral sign. Okay, then that integral equation is called a singular integral equation. Okay. Now, we can classify another classification. Types of integral equation depends on uh, limit of integration. Okay, limit of integration, we can classify integral equations into two types. Okay, depends on integral limits. We can classify into two types. So one is Volterra integral equation, another one is Fredholm integral equation. Okay, we are classified. I'm writing here types
Sir,
of.
sir,
Yes.
sir, y of
Yes.
x integral 0 to 1 by x minus 1 y of t dt singular. How, sir?
It is not defined in the interval. Here 0 to 2 means we can take the values between 0 to 2, closed interval 0 to 2. It takes all the values between
Okay.
0 to 2. It includes 1. At 1, the limit, the kernel
Okay,
1
okay,
by x
acha.
minus 1 is not defined. So that it is
Okay,
not defined. Okay.
okay, okay. Thank you, sir. Okay.
Okay. Now, the types of integral equations on that depends on limit of integration. Limit of integration. Okay, this is important. We can classify into two types. Okay, first one is Volterra integral equation or Fredholm. First, I am discussing Fredholm integral equation. Okay, Fredholm integral equation. Fredholm integral equation. Okay, now an integral equation is said to be Fredholm integral equation if both limits of integration are constants. We are already discussed the integral a to b is there, where a and b both are constants. In this case, the integral equation is called Fredholm integral equation. That means if both limit of integration, limits of integration are constants. Okay, a is constant and b is constant. Then it is called Fredholm integral equation. Fredholm integral equation. Okay, you can see the example here. If you take a equation of the form y of x is equal to e power x plus integral sum, I am taking 0 to 1. Okay, here lower limit is constant, upper limit is also constant. Sine of x minus t into y of t into dt. Y of t into dt. Here you can see the only limits. Both the limits are constant, so that this integral equation is called Fredholm integral equation. If you take another example, some y of x is equal to sin x plus integral 0 to sum 2. Okay, no need to take 0 here. You may take 1 also. Okay, 0 to 2 e to the power of x minus t into y of t dt. Y of t dt. Here the limits, both the limits, lower and upper limits are constants. This integral equation is called Fredholm integral equation. We can see the only limits, both the limits are constant, that become Fredholm integral equation. Now, another one is Volterra integral equation. Volterra integral equation. Volterra integral equation. Okay. When both the limits are constant, then that is called Fredholm. If one variable of the, okay, or in other words, in particular, the upper limit of integration is a variable. Okay. means if upper limit of integration is variable. Okay, lower limit is a constant. Then it is called Volterra integral equation. Okay, we can observe here only upper limit to be a variable. That means is equal to some 0 to x. Here we are taking upper limit e to the power of x minus t into y of t into dt. This is an example of Volterra integral equation. If we take another example, some y of x sin x plus integral 0 to, you may take 1 or 2, whatever the value. Okay, I am taking 0 to x only. Sin, here I am taking cos of x. Okay, this is another example of Volterra integral equations. Okay, depending on limits of integration, we can classify integral equations into two types: Fredholm integral equation and Volterra integral equation. Fredholm integral equation means both the limits are constants. Okay, when upper limit is a variable, then that integral equation is called Volterra integral equation. Okay, this is main type of main classification of the integral equations. You should remember Volterra integral equation form and Fredholm integral equation form. And one more classification, depending on, we are already we can classify integral equations into three types by depending on g of x. Okay, we can define first kind integral equation, second kind integral equation, third kind integral equation. ఇక్కడ మనం మళ్ళీ డిఫైన్ చేస్తాం. ఫస్ట్ కైండ్ Fredholm integral equation, second kind Fredholm integral equation, third kind Fredholm integration. Similarly, first kind Volterra integral equation, second kind Volterra integral equation, third kind Volterra integral equation. Okay, now another classification, that is depends on g of x. That is depends on g of x. Okay, first one is first kind integral equation. Simply I am writing L. Okay, the integral equation I am writing here. The integral equation, okay, we are taking general form first of all, that is g of x into y of x, that is equal to f of x plus lambda is 1. I am taking some integral a to b kernel k of x comma t into y of t dt. This is the integral equation. This integral equation is called first kind integral equation. If and only if g of x is equal to 0. This is important. Okay, when g of x is equal to 0, this integral equation is called first kind. In conversely, it is first kind means g of x must be 0. That means the integral equation f of x, here the left side will be 0. We are writing rearranging this. That means f of x plus integral a to b k of x comma t y of t dt. Okay, that is equal to 0. Is called first kind integral equation. Okay, only the condition g of x is 0. When g of x is 0, then general form of the integral equation becomes like this: f of x plus integral a to b k of x comma t y of t dt is equal to 0, and this integral equation is called first kind integral equation. Similarly, second kind integral equation. Second kind integral equation. Okay. In second kind integral equation, g of x is equal to 1. Okay. That means the integral equation, the integral equation, we are taking general form of the integral equation, that is g of x into y of x is equal to sum f of x plus integral a to b k of x comma t y of t dt. Okay, y of t dt is said to be, or is called second kind integral equation if and only if the condition is necessary and sufficient. G of x is equal to 1. When g of x is equal to 0, first kind integral equation. When g of x is equal to 1, second kind integral equation. That means the integral equation of the form, the integral equation. What is the form of the integral equation? G of x is 1 means the left side will be y of x only. That is equal to f of x plus integral a to b k of x comma t into y of t into dt. This integral equation is called second kind integral equation. Okay. Now we can define the third kind also. Okay. Now third kind integral equation. So when g of x is 0, first kind, no problem. When g of x is 1, second kind, no issue. Where neither g of x is 0 nor 1. That means it may be any variable. Never be 0, never be 1. Such type of integral equation is called third kind integral equation. That means if g of x neither equal to 0 nor equal to 1, neither 0 nor 1, then the integral equation, okay, that means a general form we are writing g of x into y of x is equal to, this is g f of x plus integral a to b sum k of x comma t, okay, is called third kind integral equation. That means g of x may be a variable. It may be x, it may be x square, it may be x cube, it may be sin x, it may be cos x, whatever the value. But it never be 0, never be 1. That means if you see the one example, sum x square into y of x. Here g of x is equal to my x square. That is equal to, we are taking e power f of x is my e power x plus some lambda into integral a to b k of x comma t into y of t into dt. This is an example of third kind integral equation. You may write another example also, like x into y of x is equal to some sin x plus lambda into integral a to b. We are taking, I'm not taking sin x. When x is equal to 0, will never be 0 means, okay. No issue. X is not equal to 0. You may take sin x also. A to b k of x comma t into y of t dt. These are the examples of integral equation of third kind. Okay. Depending on g of x, we can classify uh, integral equations into three types. First kind is when g of x is equal to 0. Second kind is when g of x is 1. When g of x neither 0 nor 1, then that is called a third kind integral equation. And another classification is depends on f of x. Depends on f of x. యాక్చువల్గా ఇంటిగ్రల్ ఈక్వేషన్స్ అనగానే మనకు ఓన్లీ టూ క్లాసిఫికేషన్ ఐడియా వస్తాయండి, వోల్టేరా అండ్ ఫ్రెడ్లో. కానీ మన క్వశ్చన్స్ అనేటివి వీటి మీద ఫామ్ చేస్తాడు, ఎలా అడుగుతాడు అనేది మనం ప్రీవియస్ క్వశ్చన్ చూద్దాం. ఓకే, డిపెండ్స్ ఆన్ f of x, we can classify integral equations into two types. Okay, first one is homogeneous integral equation. Homogeneous integral equation. Simple definition: if f of x is 0, if f of x is 0, then the integral equation general form we are writing g of x into y of x is equal to some f of x plus integral a to b k of x comma t into y of t dt. Okay, is called homogeneous integral equation. Homogeneous integral equation. Homogeneous integral equation. When do you say that an equation is homogeneous? When f of x is 0. Okay, that means the integral equation of the part. Here left side will be same g of x to y of x. F of x is 0, so it will right side becomes integral a to b k of x comma t y of t dt. Okay, this integral equation is called homogeneous integral equation. Homogeneous integral equation. Okay, only f of x is equal to 0. Now non-homogeneous. Non-homogeneous means simple, when f of x is not equal to 0. Okay, non-homogeneous integral equation. Okay, see the definition. If f of x not equal to 0, if f of x is not equal to 0, then the integral equation becomes, what is the general form of the integral equation? This is the general form. Okay, if g of x into f of y of x is equal to, this f of x becomes f of x only. Okay, so then the integral equation g of x into f of y of x. Okay, f of x is not equal to 0 means some function. Okay, it may be any function. Integral a to b k of x comma t, yes, k of x comma t y of t dt. Y of t dt is called non-homogeneous integral equation. Okay. If you take f of x is equal to either a e power x, you may take a sin x, you may take a cos x also. That means the integral equation, the integral equation, sum I am taking y of x is equal to some sin x. You may take a cos x, e power x, whatever the value, plus lambda into integral a to b k of x comma t y of t dt. This is an example is non-homogeneous integral equation. Okay. According to f of x, can classify integral equations into two types. First one is homogeneous, second one is non-homogeneous. If f of x is zero, homogeneous, otherwise non-homogeneous. And this is the classification. Okay. Now, kernel of integral equation. Kernel of integral equation. That means k of x comma t. Okay. When we take the general form of the integral equation, in the integral equation, we are taking general form g of x into y of x is equal to f of x plus lambda into integral a to b k of x comma t into y of t into dt. Okay, this is the general form of the integral equation. The unknown function, we know that k of x comma t is unknown function. The unknown function k of x comma t is called kernel of integral equation. And this kernel is said to be symmetric. Okay, a kernel k of x comma t is called symmetric kernel. Symmetric kernel. The condition, if and only if k of x comma t is equal to symmetric property k of t comma x. Okay, k of x comma t is equal to k of t comma x. In this case, the kernel is called symmetric kernel. Okay. Now, if k of x comma t, if I am taking a kernel k of x comma t is called skew symmetric kernel. Skew symmetric kernel. The condition is if and only if k of x comma t is equal to minus k of t comma x. Okay, you should remember these two definitions. Okay, symmetric kernel means k of x comma t is equal to k of t comma x. As we know that symmetric matrix A transport is equal to A, and a skew symmetric matrix A transport is equal to minus A. Like that, when k of x comma t is equal to k of t comma x, then the kernel is called symmetric. When k of x comma t is minus k of t comma x, in this case k of x comma t is called skew symmetric kernel. Okay, and if the kernel is of the form, if the kernel k of x comma t, if the kernel k of x comma t is of the form, is of the form k of x minus t. It is in the form of e to the power of x minus t. It may be sin x minus t. It may be cos x minus t. It may be log x minus t, like that. Okay. Then this kernel is called a convolution of integral equation. Then integral equation is called convolution integral equation. Okay, an integral equation is said to be convolution integral equation, means it contains the kernel in the form of k of x minus t. Okay, that type of integral equation is called. For example, if you see an integral equation, if you take I'm taking integral equation of the form y of x is equal to the integral equation y of x is equal to, I'm taking here sin x plus integral sum 0 to 1 e to the power of x minus t into y of t dt. Okay. Here we can observe the kernel k of x comma t is e to the power of x minus t. It is in the form of k of x minus t form. So it is called convolution integral equation. Is called convolution integral equation. Okay. It may be e to the power of x minus t. It may be sin x minus t. It may be cos x minus t. Okay. You can remember either in the form of x minus t. Okay. Sometimes you may call it as t minus x also accepted. Okay. We can take minus as common. Sin of x minus theta minus sin theta and cos of minus theta. Like that we can use t minus x is also applicable. In this case, the integral equation is called a convolution integral equation. Okay. Now we can discuss some questions related to these topics from SET, previous set questions. First, I'm taking one simple question. The symmetric kernel. The symmetric kernel is. Okay. What is the meaning of symmetric kernel? K of x comma t is equal to k of t comma x. Okay. We have options here. First option, e to the power of x minus t. Second option, sin x minus t. And third option, cos x minus t. And fourth option, x plus 1 divided by t plus 1. We have these four options. Okay. We can verify k of x comma t is equal to k of t comma x. Okay. If you take k of x comma t, we are discussing here. If you take first option, k of x comma t is equal to e to the power of x minus t. This is never be equal to e power t minus x. So it is not a right option. If you take k of x comma t is equal to sin x minus t. If you take minus as common, minus sin t minus x. So it becomes minus k of t comma x. Here in this case, it is called a skew symmetric kernel. So this is also not correct. If we take k of x comma t is equal to cos x minus t. So we can write cos t minus x also. Cos of minus theta become cos theta. So it is cos of t comma x. So here in this case, we can conclude that cos x minus t is the symmetric kernel. Okay, it never be equal to, if you take k of x comma t is equal to x plus 1 by t plus 1, never be equal to t plus 1 by x plus 1. Okay, so fourth option is also not correct. Okay, only third option, that is cos of x minus t is the right option. Okay, now I'm taking another question from SET. One second. It is also from previous SET question. The homogeneous linear second kind integral equation. I'm writing simply IE. Okay, it contains how many classifications? Homogeneous undi, linear undi, second kind. Three classifications unnai. Okay, first we are given options here. I'm taking first option. Y of x is equal to 2 into integral 0 to x e to the power of x t e to the power of y of t dt. First option. Second option, 3 into integral 0 to 1 e to the power of x minus t y of t dt is equal to sin x. And the third option, y of x is equal to integral 0 to x sin x minus t y of t dt. And fourth option is y of x is equal to e to the power of x plus integral a to x x into sin t. Here k of x comma t is x into sin t. That means y of t dt. These are the four options we have. Okay. First, you can see the question here. The question we have homogeneous linear second kind. First, see the homogeneous. What is the meaning of homogeneous? Homogeneous means f of x is 0. When f of x is 0 means, what is the wrong answer? Wrong option? Here in the four options.
Fourth option.
Second option.
Yes.
Fourth option.
Fourth option is wrong. Okay, it contains f of e power x. Here f of x is equal to e power x. So, therefore, fourth option is correct. I'm writing like this. Okay. Now, second condition, linear. What is the meaning of linear? Y of t is linear. Now, what is the wrong answer? Y of t linear? Is it both? E power y of t is not accepted, is it?
Yes, sir.
Okay. And second one is also e power minus t is there. Y of t means e power minus t into y of t. So second is also not accepted. That means 1 and 1 is not correct and 2 is not correct. Okay. So obviously third option is the right option. Okay. Therefore, option 3 is correct. Option 3 is correct. Why it is correct? Okay, you can see here. Last condition. Second kind. What is the meaning of second kind?
G of x is 1.
Second kind means g of x is equal to 1. So here g of x is 1. Is it?
Yes.
The left side. y of x into g of x. So this is the right option. Okay. Therefore, option 3 is right option. Okay. Like this, we can ఇక్కడ మనం జాగ్రత్తగా ఉండాలి. హోమోజీనియస్, నాన్ హోమోజీనియస్, లీనియర్, ఓకే, నాన్ లీనియర్, సెకండ్ కైండ్, ఫస్ట్ కైండ్, థర్డ్ కైండ్, ఈ క్లాసిఫికేషన్ జాగ్రత్తగా తెలిసి ఉండాలి. ఓకే, దెన్ వీ కెన్ డూ ద క్వశ్చన్. అదర్వైజ్ విల్ నాట్ డూ. Taking another question from the set, the integral equation, the integral equation y of x is equal to, I'm writing here, y of x is equal to e to the power of x plus 2 times integral 0 to 1 sin x minus t y of t dt is, we have options here. First one is homogeneous Fredholm integral equation. Fredholm integral equation. Second one is homogeneous Volterra integral equation. Volterra integral equation. Third one is homogeneous Fredholm integral equation. Homogeneous Fredholm integral equation. Fredholm integral equation
Sir,
of,
first option కూడా అదే సార్.
wait. Homogeneous Fredholm integral equation of, complete కాలేదు that option. Second kind. And fourth option, non-homogeneous Fredholm integral equation. Fredholm integral equation of second kind.
Option 4,
Second
sir.
kind. Okay. Now, what is the right option?
Option 4.
Okay. Why it is non-homogeneous? Here f of x is
F of x not equal to 0.
For x, sir.
okay.
E for x not equal.
So first see the all equations are Fredholm only. Here the both the limits are constants, so we can discard the option 2. Okay, and see the f of x here. F of x is equal to e power x. E power x is not equal to 0, means non-homogeneous. Okay, non-homogeneous ఒకటే ఆప్షన్ ఉంది కదా, కాబట్టి fourth option is the right option. Okay, when f of x homogeneous means what? In the first case, in third case homogeneous. ఇక్కడ homogeneous ఏ kind అయినా కావచ్చు. Okay, but f of x is not equal to 0 here. If f of x is 0, we can classify into, ఒకవేళ f of x 0 ఉందనుకోండి, 1 and 3 లో బెస్ట్ ఆప్షన్ ఏంటి? 1 and 3 లో బెస్ట్ ఆప్షన్ ఏంటండి? ఇంటిగ్రల్ ఈక్వేషన్ ఆఫ్ థర్డ్ వన్ చూస్ చేసుకునేవాళ్ళం. ఓకేనా, అది f of x is equal to 0 ఉన్న కేసులో. ఓకే, అదర్వైజ్ we can discuss, we can take the non-homogeneous. Okay, now I'm taking another question from set. Which of the following integral equation is first kind linear non-homogeneous Volterra integral equation. Volterra integral equation. Volterra integral equation means upper limit must be variable.
Variable.
Okay. So we have options here. First option, y of x is equal to e to the power of x plus lambda integral 0 to 1 x into e power t y of t dt. Okay, it is not correct. Okay, upper limit is constant. So take a second option, y of x is equal to log x plus lambda integral 0 to x x plus 1 by t minus 1 y of t dt. And take a, it may be correct. Okay, we can check whether it is correct or not. And take the third option, sin x is equal to e to the power of x plus lambda integral 0 to x t plus 1 by x minus 1 y, here x minus 1, this is my x minus 1 y of t dt. This is third option. And fourth one is sin x is equal to lambda integral 0 to 1 t plus 1 by x plus 1 y of t dt. Okay, obviously first and fourth options are not correct.
Third
Okay,
answer correct, sir.
third answer is correct. Okay,
Yeah, sir.
yeah. What is the meaning of linear?
Order.
Linear means what? Y of t is linear. Y of t is linear. Okay, that means it is linear in t. T లలో linear కావాలి. ఓకేనా? So which is linear? Either 2 or 3.
3.
Yes. Linear. Linear means y of t, a linear in y of t. First of all. Okay. So in the second option, t is not available in the numerator. If you, here in the third option, we have t here in the numerator. If we multiply with the y of t, that means a function of t contains more than 1 degree. More than 1 degree. So what is the right option?
Third answer.
2, sir.
Option 2 or option
3, sir.
Okay, for 1 second. Both are same now. Sin x, y of x. Okay. Why it is 3? 3. Why it is 3? 1
3.
second. Y of
This
x
is
equal.
Y of x, g of x is equal
kind.
to first kind.
First
Yes,
kind means
yes.
g of x is equal 0.
Yes, we have another condition is also there. That is first kind. What is the condition for first kind?
G of x is equal to
0.
G of x is equal to
0.
1, 0 na 1 na?
0, sir.
0, sir.
G of x is equal to 0. Okay.
Yeah.
So third option is right.
Yeah, sir.
Okay. So we can know the classification of the integral equations.
థర్డ్ ఆప్షన్ జీ ఆఫ్ ఎక్స్ ఇస్ ఈక్వల్ 0 అయితే 0 అవుతుంది కదా సార్.
1 second. First kind.
Sin x plus sin x will be trans.
సార్ థర్డ్ ఈక్వేషన్ ని కన్వర్ట్ చేయొచ్చు కదా సార్. sin x
Plus sin x will be transposed to minus sin x.
sin x అవుతుంది.
So
is
that
equal
means
to
that is 0.
Next side 0.
is equal to 0 కదా అండి. is equal to 0 కదా అండి. దీన్ని ట్రాన్స్ఫర్ చేసుకోవచ్చు కదా.
ఓకే
అవును సార్.
Okay. Okay. And now, yes. Now, see the another concept. Very important and one more question we can see here. The integral equation from set, the integral equation y of x is equal to e power x plus 2 into integral 0 to 1 sin x minus t y of t dt is, okay. This I'm sorry, this is we did. Okay. I'm sorry, this here we have e to the power of x minus t, e to the power of x minus t into y of t dt is, okay. Options, first option, homogeneous Fredholm integral equation, first option. Second option, homogeneous Volterra integral equation. Third option, non-homogeneous Volterra integral equation. And the fourth one is non-homogeneous Fredholm integral equation.
Fourth option is correct, sir.
Fourth option.
Okay. We know
Fourth
that limits of the integration are constant, so it is Fredholm. Okay.
Fredholm.
Second and third will be cancelled, and we can see the homogeneous. Here f of x is equal to e to the power of x, that is not equal to 0.
Not equal to 0.
Not equal to 0 means it is non-homogeneous. Okay. So non-homogeneous means fourth option is the right option of the this problem. Okay. Now we can see the another concept, that is solution of linear integral equation. First we can, okay, we'll discuss in the next class. If you have any question, you can ask. Anyone? Do you have question? You can ask. How many are attending? 60. Okay. Any questions regarding this? We'll continue in the next class. Okay. How to find the solution of integral equation? First we can see the how to solve find the solution of the integral equation in general form. Then we'll discuss the shortcut tricks. Okay.
Thank you, sir.
Any
much. Any clarification amma and doubts unte adigandi deen meeda. So every time మనకు CSR net లో కనుక 2 లేదా 3 క్వశ్చన్స్ వస్తున్నాయండి. 2 క్వశ్చన్స్ కంపల్సరీ ఇన్ TG సెట్ అండ్ CSR net ఎగ్జామినేషన్. పోయినసారి కూడా TG సెట్ లో CSR లో 2 వచ్చినాయి కదా సార్, ఒకటి 4.75 వచ్చింది.
yes sir
సో నేను ఖచ్చితంగా మనకు TG సెట్ ఎగ్జామినేషన్ లో 2 క్వశ్చన్స్ వస్తాయండి. సో 2 into 2 4 మార్క్స్. అట్లా మనము గన్ షాట్ గా ఉండే టాపిక్ సెలెక్ట్ చేసుకోవాలి. గన్ షాట్ గా ఉండే టాపిక్స్ లలో ఇందులో 2 క్వశ్చన్స్ వస్తున్నాయి. సిఓవిలోకి వెళ్ళి 2 క్వశ్చన్స్, ఆపరేషన్ రీసెర్చ్ కి వెళ్ళి 2 క్వశ్చన్స్, మార్కో చైన్ కి వెళ్ళి 2 క్వశ్చన్స్. అంటే చిన్న టాపిక్స్ కంపల్సరీ వచ్చే క్వశ్చన్స్. వీటి మీద కూడా మేము కాన్సన్ట్రేట్ చేసి చెప్పించే ప్రయత్నం చేస్తాము. సో థ్యాంక్ యూ వెరీ మచ్ సార్, నైస్ సెషన్. యా, ఎనీ క్లారిఫికేషన్, ఇంకేమైనా డౌట్స్ ఉంటే అడగండి.
Any questions regarding this? Okay.
యా, కొంతమంది ఇంపార్టెంట్ టాపిక్స్ ఏంటి అని అడుగుతా ఉన్నారండి వాళ్ళు. సో మీకున్న టైము 2 months ఉందండి. ఇంకా దాదాపు 30 + 30 60 days టైం ఉంది. 60 days టైంలో పేపర్ 1 పేపర్ 2 రెండు చదవాలి. కాబట్టి మేమిచ్చే అడ్వైజ్ ఏంటి అంటే లీనియర్ ఆల్జిబ్రా, కాంప్లెక్స్ అనాలిసిస్, రియల్ అనాలిసిస్, COV క్యాల్కులస్ ఆఫ్ వేరియేషన్, ఇంటిగ్రల్ ఈక్వేషన్స్, సో ఇంకా ఇంతకుముందు చెప్పిన మార్కో చైన్ కానీ, ఆపరేషన్ రీసెర్చ్ కానీ, ఇంకా అవసరమైతే ODE PDE. ఓకే, ఇంకా టైం దొరికినప్పుడు అప్పుడు మీరు అబ్స్ట్రాక్ట్ ఆల్జిబ్రాలో కొన్ని కాన్సెప్ట్స్ టచ్ చేయాలి. సైలోస్ థియరమ్స్ కానీ, ఇర్రెడ్యూసిబుల్ పాలినామియల్స్ మీద కానీ. సో వీటి మీద టచ్ చేసినట్లయితే మన క్వశ్చన్స్ ఎక్కడి నుంచి వస్తుందో గెట్ చేయడానికి ఆస్కారం ఉంటుంది. రైట్. సో థ్యాంక్ యూ వెరీ మచ్. హ్యావ్ ఎ నైస్ డే. గుడ్ నైట్ ఆల్ ఆఫ్ యూ. ఐ థింక్ నో డౌట్స్, ఏ డౌట్స్ లేవనుకుంటాను. ఓకేనా?
ఓకే సార్, థ్యాంక్ యూ సార్.
యా, ఈ మనకు ఇంటిగ్రల్ ఈక్వేషన్స్ లో మేబీ 6 to 7 క్లాసెస్ అవుతాయండి. అది అయిపోయిన తర్వాత
Okay,
ఖచ్చితంగా ప్రతి స్టూడెంట్ కూడా సిఎస్ఐఆర్ కానీ టీజీసెట్ ఎగ్జామినేషన్ లో క్వశ్చన్ మస్ట్ గా అటెంప్ట్ చేయగలుగుతారు. am I right సార్?
ఎస్ సార్, అబ్సల్యూట్లీ సార్. కంపల్సరీ క్వశ్చన్ అటెంప్ట్ చేస్తారు. విత్ ఇన్ 1 minute వి విల్ డూ ద క్వశ్చన్. ఓకే,
ఎస్, ఆ కాన్ఫిడెంట్ అయితే మేము ఇస్తున్నామండి. మీరు జస్ట్ స్మార్ట్ వర్క్ అప్లై చేయండి. ఇక్కడ మనకు ఉండేది వాల్టర్ ఇంటిగ్రల్ ఈక్వేషన్, ఫ్రెడెల్-హోమ్ ఇంటిగ్రేషన్, రీసాల్వెంట్ కెర్నల్స్, ఈ మూడింటి మీద అడుగుతా ఉన్నాడు. కొన్నింటి మనం వెరిఫై కూడా చేసుకోవచ్చు. సార్ మీకు నాలెడ్జ్ త్వరలో ఇస్తారు. థ్యాంక్ యూ వెరీ మచ్ సార్. నైస్ సెషన్ సార్. సార్ నైస్.